Fine. So far we have seen how a machine code is placed in the hard disk of a computer, right? Fine. Now let's see what do we really mean by operating system. Let us assume that our RAM can hold a maximum of 50 programs, right? Let us assume that the capacity of the RAM in such a way that it can hold a maximum of 50 programs in it. Also, let's assume that our hard disk can hold 500 programs, and as you know, size of hard disk will be larger than size of RAM. Fine. See, we have already seen that our CPU cannot access the hard disk directly, right? Any program our CPU wants to access, it can only access the RAM directly. Now, so definitely we need to move the program from hard disk to RAM, right? Only then CPU can execute it. Now my question is, since RAM can hold only 50 programs, out of these 500 programs, which 50 programs are you going to move to RAM? Right? Only 50 programs can be moved from hard disk to RAM. Now out of this 500 programs in the hard disk, which 50 programs are you going to move to RAM? Right? That is the question. See, one answer you might come up is we need to move the 50 programs which the CPU will request next in the future, right? The 50 programs which CPU will be most likely to refer next, right? Why? Because in case if the program which CPU is asking for is present in the RAM, it will take very less time for the CPU to execute, right? Whereas in case if it is not present in the RAM, we need to access the hard disk, so it is going to take a lot of time. So you might say that we need to keep the 50 programs which is most likely to be requested by the CPU next, right? But there is a big problem here. The problem is we cannot tell the future exactly, right? Our CPU can ask for any program. We don't know which 50 programs will the CPU refer next, right? We cannot exactly tell the future. So for that, there is no other way other than going for prediction, right? We go for prediction, which means we try to predict which 50 programs will the CPU is most likely to refer in the near future, right? Only those 50 programs we need to move from hard disk to RAM, right? Those programs need to move from hard disk to RAM. Now there are various algorithms we can write. We can come up with various algorithms saying that this 50 programs has to be moved, that 50 programs has to be moved, right? It really depends on algorithm which we are implementing. That algorithm will be implemented by our operating systems, right? That algorithm will be implemented by our operating system. See, this is how our operating systems will look like. It is a big program which will have a lot of functions, right? And every function will implement a particular functionality. Here our operating systems need to choose 50 programs among this 500 programs, right? This is one such functionality. Now this functionality will be implemented by one of the functions of operating system, right? One of the functions of operating system will be implementing this functionality. Now we can also say this functionality as long-term scheduler. The part of the program which is selecting this 50 programs among the 500 programs is also called as long-term scheduler. So our operating systems is a big code out of which long-term scheduler is a small function, right? Which is going to implement the selection of processes from hard disk to RAM. Fine. So this point is very clear, right? Actually, what we are doing here, we are doing nothing but resource allocation. We are doing something called as resource allocation or resource management. Why? See, any device we use in our computer, we can also say them as resource. For example, CPU is a resource, RAM is a resource, hard disk is a resource, even printer is a resource, mouse is a resource. Any device you use in our computer is called as a resource, right? It can be any device. Fine. Here the device is nothing but RAM. By resource, here we mean the RAM. Why? Because 500 programs are trying to access the RAM, which is the resource. Now it is the operating system which is deciding which 50 programs should access the RAM, right? Which 50 programs among these 500 programs, which 50 programs should access the RAM. So operating systems is clearly implementing resource allocation, right? Resource allocation or resource management. Here resource is nothing but RAM, right? So this RAM is the resource which is being exactly allocated by using our operating systems. Similar way, there are a lot of resource allocation schemes which are necessary in order to make our computer work. For example, let me come up with another scenario. Let us assume we have two processors named P1 and P2 inside our RAM, right? We have two processes named P1 and P2 inside our RAM. Now our CPU needs to fetch the program and then it needs to execute it, right? Our CPU needs to fetch the program and then it needs to execute it. Now let us assume that both these programs want CPU, which means both these programs are ready to be picked by CPU for execution, right? Now among these two programs, which program should the CPU select next, right? Among these two programs, again there is a confusion here, right? Here the resource is nothing but CPU. CPU is the resource and more than one process is competing to access that resource, right? Now which program, see program or process both mean one and the same, right? There's a minor difference. We will see that a bit later. As of now, think that program and process both are same. Fine. Now out of these two programs, which program should access the resource? Here by resource I mean the CPU, and that is being again decided by one of the functions of operating system, right? One of the functions of operating system. Now this function will have the code which will clearly say which process among these two should access the CPU, right? That is, see how this is done by using an algorithm. For example, we might come up, why do we need an algorithm here? For example, this function might implement an algorithm saying that among these two processes, the process which is biggest in size should access the CPU first, right? Or it can implement a different algorithm saying that the process which is smallest in size should access the CPU first, right? That is one such algorithm. We can implement a lot of algorithms. Another example is the process which came into the RAM first from hard disk should access the CPU first. See, one more important point. Obviously, every program or process will definitely get the resource. There is no doubt about that. Even here, all these 500 programs will definitely be moved to RAM at some point in time, right? It will be definitely moved. Now, out of this 500, which 50 should be moved first? That is important, right? Though all 500 programs will get the resource, which 50 should get the resource first? That is important. Same is the case here. Out of these two processes, though both the processes will get the CPU, now the question is which process should get the CPU first? That is important, right? And that is being decided by our operating system, right? This functionality which decides which process should access the CPU first is called as short-term scheduler. This functionality is also called as short-term scheduler, right? We'll see that later, okay? And we are not actually discussing the advanced concept. I'm just giving you an idea. Among this 500 programs, 50 programs is being chosen by a functionality called as long-term scheduler, right? Long-term scheduler. And out of these many processes, which process should acquire the CPU first is being decided by our short-term scheduler, right? So what is actually happening is, again, resource allocation is happening. Why? Because here the resource is nothing but CPU. Now if more than one process is trying to access the CPU, and our operating system is actually allocating the resource to the appropriate process, right? So the important point you need to notice from this video is the main functionality of operating systems is resource allocation or resource management. Both are same, right? Operating systems is a code which will have lot of functions, and the main functionality of operating system is nothing but resource allocation or resource management. Fine.